Welcome back to our next video on trigonometry. So in the last video we discussed about the various trigonometric ratios, and we also discussed about uh, the values of the important angles, the sine, cos, and tangent values of the important angles. Now we are going to learn the next important topic of trigonometry. It is very important for you to understand fundamentally this concept. So what we are going to do now is that we are going to derive two very important and very basic trigonometric equations. So what we have drawn here is we call it as unit circle. When we say unit circle, it means it's a circle with the radius 1 unit. Now really we are not really bothered about what are the you know unit of measurements like with mm or cm or meters. It is just 1 unit. So now, when we say 1 unit, then what we mean to say is that so let's give some names to it. Let the circle be at the center, it's O. Now, what we have done is that we have drawn a radius. Let's do it here. Yeah. Oops. R. I'm sorry. It's actually 1 unit. This radius, or you can say this radius to be very precise, is basically 1 unit. Let us not write it here, because we'll need this space. Line tool is better. Yeah. So this radius is 1 unit. Okay. So what we have done is that we have drawn a circle with a radius of 1 unit, and we have drawn this line which connects the center with the circumference, and let us take this point as P. Now what we are trying to here do is that we have taken it as a circle on x and y axis. This is x and this is y axis, and the origin of this x and y axis is the center of the circle. So the at origin the points, the coordinates are going to be 0 0. It means x coordinate is 0 and y coordinate is also 0. Now what we are going to do here is that we are going to assume some point on this circumference, say OP, let it be Q. Now what are going to be the coordinates of Q? Let the coordinate be A and B. When we say A and B, so what exactly we mean is the value of x. Here the x coordinate is A and the y coordinate is B. So what we do is that let us draw a perpendicular or altitude from Q to this line OP, and an perpendicular from Q to this y axis. Okay, cool, looks good. Now this value on the x axis is what? This is A. This is B. Hence this length is going to be what? This length is going to be A and this length is going to be B. Now we know that this angle is 90 degree. Now since these two are perpendiculars, so this angle is also 90 degree. So we form here, what we form here is basically a rectangle. So if in case it's a rectangle, then this, if this length is B, then this length is also B. And if this length is A, then this length is also A. Now, what you do is that draw one more radius from O to Q. Now, I hope you understand why I'm calling it radius, right? Any point which connects the center of the circle to the circumference is radius. Okay. Now, what is the value of this radius? It's 1, right? Okay, it's a unit circle. So, sorry. This is 1. Now, I hope you guys remember the Pythagorean theorem. What does it states? It states the square of hypotenuse is equal to sum of the squares of the two sides. Now, what are the two sides in this circle? In this triangle? What triangle I'm talking about? Okay, let's assume a point R. So, in this right angle triangle, this is one side, that is the base, and this is perpendicular, and this is hypotenuse. Okay, so the square of hypotenuse is equal to the sum of the squares of two sides. And what are the two sides? It is A square plus B square. Now what is the hypotenuse in our triangle? This value. So it is 1 square is equal to A square plus B square, or A square plus B square is equal to 1. So let's mark this equation. Let's mark this equation as 1. Now, coming back to our mnemonic, Pandit, Badri, Prashad, Har, Bole, or So, Ka, Toa. And here what we are going to take is, we are going to take the sine function and the cos function. Now, if we say that this angle say is theta. Now what is going to be the sine theta? It is perpendicular over hypotenuse or opposite over hypotenuse. So I'm going to take both, because this is something which you're going to see in your textbooks, and this is what I most of the times I use whenever I teach trigonometry. Yeah, this H is not correct. Okay, cool. Looks good now. So sine theta is what? It is perpendicular over hypotenuse. What is the perpendicular? It is the B. And what is hypotenuse here? This is hypotenuse. What is it? It is the radius, right? And what is the value of this radius? It is correct 1. So it means sine of theta is equal to B. Let's take cos of this angle, cos theta. Again refer to our Panditji. It is base of hypotenuse or adjacent over hypotenuse. So again I will repeat. This is the angle theta. This is the side which is adjacent to this angle. This was opposite. This is adjacent, right? So adjacent is what? Our base. And what is the value of our base? It is A. And hypotenuse still remains the same, 1. This implies cos theta is equal to A. Now, what we do is that this is the equation which we just made. We will put the values of A and B in this equation. So what is A? A is cos of theta square plus sine of theta square. This equals to 1. And the way we can also write this as cos square theta plus sine square theta is equal to 1. This is the equation which we have derived, which is one of the very important equations which we are going to use quite often in our in trigonometry further. And I guess this is one of the first equations which we have to learn. Now with this, after you have understood the fundamental concept behind this equation, I'm sure that it's not that you have to memorize it. It will get what do you say, embedded into your DNA, as long as you are studying trigonometry. Sine square theta plus, and this is also said as sine square theta plus cos square theta is equal to 1. So more than often you're going to use it as sine square theta plus cos square theta is equal to 1. Now, we'll derive one more equation from here. How do we do that? Let us divide both sides by sine square theta. Now what it makes is, let's use this space. Yeah. Sine square theta plus cos square theta. This all gets divided by sine. I'm sorry. We have to divide it by. In fact, we could have divided by sine square theta as well, but let us divide it by cos square theta. Okay. Let's make the change here as well. Cos square theta. Now what happens in equations is that if we divide or multiply both the sides by the same number or same term, then the equation still remains unchanged, right? So on the left hand side, what we have done is that we have divided sine square theta plus cos square theta by cos square theta. To ensure that the equation doesn't change, we divide this side also by cos square theta. This implies we can also write it as sine square theta by cos square theta plus cos square theta by cos square theta. This is equal to 1 over cos square theta. Look, I'm sure, by the time you're watching this video, you've already, done your basic algebra. So if you have done your basic algebra, I guess, from, you would have not written this step. But I still feel that, there's no harm in, writing a couple of more steps as long as it ensures that you do not commit a mistake. Writing a couple of steps extra, most of the times, it helps prevent some unwanted mistakes. Okay, cool. So, what is sine square theta by cos square theta? Remember when we studied these? Okay, it was in a different video. Okay, cool, no issues. So, when we were in the first video, when we were talking about the trigonometric ratios, what we said? We said sine theta by cos theta is equal to tangent of theta, right? So what does this become? This become tangent square theta plus this cos square theta cancels this cos square theta and this makes it 1. And what happens to this? Okay, so you are going to learn a new term now. I wish I should have told you that before before I did this video. But anyways, we'll cover that up. Now this is the now so there is okay. So I'll just tell you before I actually give a name to it. So we'll use this space. So we have got fundamental ratios as sine theta, cos theta, and tangent theta. What we also have is the reciprocal ratios of these. So when you take reciprocal of sine theta, it means we're talking about 1 over sine theta. This we call as cosecant theta. 1 over cos theta is called as secant theta. And 1 over tan theta is called as cot theta. I wish, instead of cosecant, we had something here which starts with S, so S and S could have been easy to remember. But anyways, we can't help it, right? So inverse of sine theta is cosecant theta, and inverse or reciprocal of cos theta is secant theta. Similarly, reciprocal of tangent theta is cot theta. So what this equation will become? This is 1 over cos square theta. So 1 over cos is what? 1 over secant theta. Sorry, secant theta. So this will become secant square theta. This implies tangent square theta is equal to sec square theta minus 1. We haven't used red much today, right? So let's use it red here. So this is our second important equation. Now, and these two equations are very important and we are going to use more than often, in trigonometry. Now I wonder whether you have a question in mind that our basic assumption was it's a unit circle. Does it mean that these equations hold good only when the radius of the circle is 1? Absolutely not. Let's assume the radius of the circle was, instead of 1, 2. So what is it? Oh, let's assume that radius of the circle was 2. What happens is that now hypotenuse is, instead of 1, becomes 2, and this becomes 2, right? Will this change? Just think over it. Will this change? No, this won't change. Will this change? Will still remain as B. Let us do it here itself. So we'll substitute the values in our this equation. Plus B square is equal to 4. Now what is the value of A here? How do we find the value of A? We took sine of theta, correct? So let's say what is sine of theta? It is perpendicular over hypotenuse. What is our perpendicular? B. What is our hypotenuse? 2. What is cos of theta? B over hypotenuse, that is base over hypotenuse, and it is A by 2. B is equal to twice of sine theta, and A is twice of cos theta, right? Now coming back to the equation which we wrote here. H is hypotenuse is 2, B is and A is twice of cos theta. From where do we get this? We get it from here. So, putting it back in our Pythagoras theorem, square of hypotenuse, 2 square, is equal to sum of the squares of the two sides. 2 sine theta whole square plus 2 cos theta whole square, which makes it, so let's change the sides, 4 sine square theta plus 4 cos square theta, and this is equal to 4. What we do here is that we take 4 common, so it makes it sine square theta plus cos square theta is equal to 4, and what we do is that we cancel 4 with 4, which makes it here as 1, So this equation now becomes sine square theta plus cos square theta is equal to 1. Is it different from what we derived earlier? Absolutely not. It is exactly the same. So what does it mean? It means that in meter of whatever the radius of the circle is, the I'm sorry, the result is going to be the same. We took unit circle only for the ease purpose, so that our calculations are little easy and less painful. So this brings us to the end of this video. I'm sure now you understand how to derive these two equations, and since you now understand pretty well how to derive these equations, you're never going to forget these equations. Next video we are going to come up with another concept. So we are going to come up with another concept of how do you measure the angles. Is degrees the only way to measure the angles, or there is some much more mathematically correct or mathematically relevant way to measure an angle? That's also a pretty important part of trigonometry. So till then, practice, study, enjoy, take care.